distillation. We're going to practice simple distillation and fractional distillation. As the pre-lab discussions, I will talk about the advantage, disadvantage, or when you would use simple versus fractional distillation. We talk about some of the points that you have to follow for setting up distillation apparatus and the difference between the simple and fractional setup. First of all, the purpose for the experiment, learn how to perform simple and fractional distillation. Simple and fractional distillation are used to purify or separate component of mixture of two liquids. They must have different boiling points in order to be able to separate them by distillation. And while you are doing distillation and separating, you can also measure the boiling point of each of the components. When the sample is boiling or when the sample is being distilled and the temperature stays constant, that temperature or constant temperature during distillation can be recorded as the boiling point for that compound. If one of the compounds is more volatile than the other, that means now a boiling point of the two compounds, they are significantly different, then you can use simple distillation. That cutoff, I mean, different sources, they put different numbers, but what I have here in the lab manual is 80 degrees. So if the temperature or boiling point of one of the compound with low boiling point and the compound with the high boiling point in the mixture is 80 degrees or higher, you would confidently use simple distillation. If the boiling point difference is less than 80 degrees, then you would use fractional distillation. So we're going to look at the setup for simple distillation versus the fractional distillation. The setup is for simple distillation. We have what happens or what is involved in distillation. We have vaporization, so we have a boiling flask, the liquid is going to vaporize. And we have condensation. This is a condenser. The vapor, as it forms, is going to go through to the distillation head, and it's going to be transferred to the condenser, and it would change to liquid, and you collect in the receiving container. The receiving container, it could be flask, it could be graduate cylinder, it could be like boiling flask or Erlenmeyer flask, but that's what I mean by the flask. Either one of them could be. When you are connecting these, you want to make sure that first of all you have your stands, the ring stands, you have the clamps to hold everything and support it to the ring stand. The heating mantle cannot be connected to the wall. So you want to, those are the points to remember for this experiment. It has to be connected to power regulator. This picture here shows the power regulator, so it's the same for the simple distillation. The heating mantle should be attached to or connected to power regulator, and you adjust the voltage by rotating, by allowing, like, by the changing the resistance. It goes from 0 to 100%. When it comes to a fractional distillation, you have a fractionating column. This fractionating column is going to separate the compounds that has higher boiling point from the one with the lower boiling point. If you notice here, when you get if you have a mixture of A and B going to the vapor phase, both of them is going to go to make it to condenser, and then you get a mixture of A and B in the receiving flask, because there's nothing to hold it back, unless one has much higher boiling point that it will never boil, or it's a solid compound, or it's or inorganic salt with very high boiling point. But if for the fractional distillation, if both of them, A and B, compound with high and low boiling point, mix to the condensed to the fractionating column, if it comes up, it's going to hit this fillings that we have inside this fractionating column. Basically, those are kind of the obstacles that when the vapor reaches there, the vapor with the high boiling point is going to condense and it goes back. Only the compound with the lower boiling point is going to make its way to the distillation head, and it will go through the condenser, get liquefied again, and collect in the receiving flask. See, what's here also, I didn't talk about for simple distillation about water, circulation of the water. Condenser has like two layers. The inner layer, the vapor would go through, but the outer layer is the circulation of the water. So we have like a gentle flow of water in the air, the water condenser, to cool off the vapor. So when the first compound is going to be distilled, and the second compound or the liquid would get rich in the second compound. And this theory is explained in the lab manual. If you read it carefully, it's very easy to understand with the diagram that is also showing. But you see that the apparatus, it's different. The setup is different. For fractional distillation, you have the fractionating column. I always used utility clamp to hold the flask, but for the condenser or fractionating column, a 3-finger clamp is used to hold. When you see in the video or for face-to-face classes, when you are in the lab, you see that the 3-finger clamp, they have adjustable length and the angle, so it makes it possible for adjusting the height and the length of the clamp. For the receiving flask, depends on the height. If the height is is at the lower level, like the simple distillation, you can keep the receiving flask on the bench top. But if it's higher, you have to hold it with a clamp or have a support underneath. The water is going to go in from the lower end and it comes out from the upper end because you want the condenser to stay filled up with water at all the time. We can measure the boiling temperature of the vapor, but the temperature stays constant and you're receiving the liquid as the boiling point. And how do you justify that? Because boiling point is the equilibrium between vapor and the liquid. So you would see that when the liquid is being condensed, or the vapor being condensed, you also have a liquid at the thermometer bulb, like covering the thermometer. So basically this liquid is and the vapor is passing through here and going to the condenser. This liquid here is at the equilibrium between the vapor and the liquid, and that's the thermometer is measuring the temperature. Just have to make sure that you look for the constant temperature to record the boiling point. How does the fractional distillation work, or how is that different from simple distillation? In order to explain that, you can use the combination of the Raoult's and Dalton's law. What is saying that the vapor produced by a mixture, if it's two miscible compound, and the amount of the vapor that is going to be contributed from each, it depends on the vapor pressure and also mole fraction of each of the components. So if the impurity is kind of low, that means, let's say if you take the B as the impurity, if the impurity is low, then the contribution of the vapor from B is going to be lowered or at the beginning. Or if the vapor pressure is low for the B, that means the boiling point of B is very high. At the beginning, you would get vapor that is rich in compound A. And as the A leaves the boiling flask, it gets richer in B. So it depends on both the vapor pressure and the mole fraction of both. So this diagram here, how does the fractional distillation is working, is saying that if you have a compound B at the boiling point of the B and a compound A with the boiling point of A. When you have a mixture, let's say you have a 25% A, 75% B, when it starts boiling, it's going to reach the boiling point at the temperature X, which is this point here, point A, the sample starts boiling. If you look at this curve, the lower curve is showing the boiling or concentration of the sample at the liquid phase, and the upper curve shows the mole fraction or concentration in vapor phase. So if we have the 25%, 75% of A and B at temperature X is going to start boiling. But when you look at the vapor composition here is going to be 74% A and 26% of B, because of the vapor pressure of the B being low, so you get more of the A in the vapor. And when it does condense, it's going to condense at a lower temperature. So in this temperature, you have, if you cross this point again, is going to give a much higher percentage of A. And if you repeat this theoretical plate or this vaporization condensation that kind of goes like stepwise 2 or 3 times, you would get almost pure sample of A. So fractional distillation, it's multi-step of vaporization condensation, versus for simple distillation, it's just one time. One step of vaporization condensation. So for simple distillation, you might get a product that is, or distillate that is going to be rich in A, but for fractional distillation, because that distilled liquid is not going to the condenser, or the vapor, and this step is not going to condenser yet. There's another vaporization and condensation, or maybe it's third one or more, depending on the height of the fractionating column and the surface contact surface area inside the fractionating column. You could have multiple theoretical plate, and each theoretical plate is known as one set of vaporization condensation. The greater number of that, more efficient would be the separation by fractional distillation. So you can also, so in this reaction experiment, we are separating the component of the mixture for 2 liquids for fractional distillation, a liquid from a solid for simple distillation. And what you want to remember, because you're also measuring the boiling point of the liquids, you want to adjust the height of the thermometer properly. The thermometer must be below the level of the condenser. So this is the 3-way adapter or distillation head. One way is going to condenser, one is attached to boiling flask, or the fractionating column, and one is holding the thermometer with the thermometer adapter. This thermometer bulb should be lower than the level of the condenser. If it's too high, it would record lower temperature. If it's too low, it's recording the higher temperature. Maybe you have a mixed vapor, or affected by the temperature of the liquid. When we are measuring boiling point, we should measure the temperature of the vapor at the equilibrium with the liquid. For other points to remember for distillation, you want to make sure that you are going to use the boiling chips. The purpose of using boiling chips is to make sure that the boiling is gentle and there is no bumping. So if there is no boiling chips in the boiling flask, your sample can boil in one area and then starts like bumping, and bumping can make the liquid go through the condenser, and the separation is not going to happen. At least it's not going to be efficient. Greasing glass joints. You must grease the glass joints for two reasons. One, to make sure that there is a sealed system. You don't want the vapor to escape from any opening. Second, when you are heating two glass pieces that are connected to one another, it can freeze together. So if it's not greased properly, it will be stuck and freeze together, and it would be hard to separate them when you are done. Heating the sample gently is another point for distillation you want to remember. If the sample is heated too fast, there are two problems, multiple problems. It could be bumping. Basically, liquid can jump into the distillation head or the condenser. Too much vapor can be produced. If it's too much vapor produced, then condenser doesn't have enough time to condense all the vapor. Some of the vapor would leave through the vacuum adapter or the opening of the receiving flask. And separation is not going to be efficient because you get both compounds, and you give enough energy to both compounds to evaporate at the same time. So basically you are co-distilling. Position of thermometer, we already talked about it. And how close are the boiling points is important. If it's 80 degrees apart from each other, you could use simple distillation. And if it's less than that, you would use fractional distillation. If you have two liquids that they have same boiling point, you cannot separate them by distillation. When you're done with distillation, when would you stop distillation? To stop distillation, you're looking for collection of desired volume. Let's say procedure asks for 30 milliliters, you collect the 30 milliliters, you stop. If the boiling flask is about to be dry, you have to stop distillation. You cannot continue distillation if there is not enough liquid in the boiling flask. Sometimes you see like a fog or white cloud inside the boiling flask. At that point, you also have to stop the boiling. Gentle boiling is the key to avoid all consequences, okay? Which could be the bumping, and it could be the losing of the vapor. And when you collect your distillate and you record the boiling point for the compound or two compounds for fractional distillation, you record the boiling points and you try to identify your compound. You can identify the compound from the boiling point, but if you look at this table as like if you have possible compounds, you have water 100 degree and propanol 97, propyl acetate 101. So if you get any number like around 97, 98, 99, it would be hard to say which one of these compounds is. So we are adding a second physical property, and that second physical property is the refractive index. You measure the refractive index. In the video, I show you how to use the machine. The refractive index from the literature value is recorded at 20 degrees Celsius. And when you measure the refractive index in the lab, you have to use this formula given in the lab manual to correct for the 20 degree using the formula and looking at the difference between the observed and the 20 degree. So you can compare the calculated with the literature value. The closer the value is to the literature value, that means the more pure your sample is. And if your sample is unknown, you can actually use the refractive index and the boiling point together in order to find the name for your unknown sample. And as I said, this is just to help you. This pre-lab discussion is to help you to do well on the pre-lab quiz. You also want to make sure to read the experiment. Before you take the pre-lab, read the experiment carefully, because the questions they are asking like detailed information about the experiment, but all the answers can be found in the experiment, within the experiment. Like the pre-lab quiz for distillation, just read the experiment for distillation, you will find all the answer. The pre-lab discussion does highlight the purpose of the experiment and why some points to remember, which are very helpful for some of the questions in the pre-lab assignment. Thank you. This is the second experiment. I hope that at this point you already know how to study to do well on the exam, and then on the quiz and exam. And also the pre-lab discussion is going to help you to understand the purpose for the experiment. So when you are watching the video for the experiment, how it's done and what is being measured, you already know what to look for. Thank you.